Today's lesson is about 5.2 rates and unit rates. The first thing I want to do is go over a little bit of a review from our lesson from yesterday. If you remember yesterday, we talked about what we have to do if we are moving from the top to the bottom of our graph. What do I have to do? Divide or multiply? Divide. Very good. And then the opposite, if I am moving from the bottom to the top, I have to multiply. Okay, so we're going to have to remember that as we try to find the value of the ratio. Does anyone remember how to do that? Ava, what do I do? You are correct. We're going to take 10 divided by 4. Now, if you look over here, this is a decimal, which means my answer is going to come out as a decimal, not as a fraction. So just stick it in your calculators, guys. What's 10 divided by 4? 2.5. As you remember, we talked about before, where else can I put that value of the ratio? All the way across the entire table. Now let's remember how we did it yesterday. Do I have the top number or the bottom number here? Top. It gave me the top number, 18, so I'm working from the top to the bottom. Should I multiply or divide? Divide. Guys, what's 18 divided by 2.5? 7.2. 7.2. Good job. I'd like you to do the last two boxes on your own. All right, guys, that next one, we're working from the bottom to the top, so we have to multiply. What'd you get? 15. And the final one, we're working from the top to the bottom, so what do I have to do? I'm going to divide, so what's the answer? 9. Now it asks us to write the equivalent ratios. If you remember with this, I no longer need this part in the middle. I don't need the missing link. I'm just comparing the first value, x, to the second value, y. What will I write for the first one?
10 to 4.
10 to 4. Talila, what's the next one?
18 to 7.2.
Brayden, what's the next one?
18 to 7.2.
Okay, we just did that one. What's the next one?
15 to 6.
Good job. And Trenton, the final one.
22.5 to 1.
Very good. Okay, then box that in, guys. Those are our equivalent ratios. All right, the first word we see here is a rate. Now, this is a ratio or a comparison. Remember, we talked yesterday about how to compare things of two different quantities using different units. What does the example say there?
16 miles divided by 4 hours.
Okay, 16 miles per 4 hours. Notice those are different units. I have miles and I have hours. Let's look at the next one, the unit rate. This compares a quantity to 1 unit of another quantity, and it has to have a denominator of 1. Let me have you guys underline that, because that's the main thing you really got to know about a unit rate, is that you must have a denominator of 1. So now with a ratio has to be the same units, but a rate has different units. So what we talked about yesterday, once again, had the same units, but today we're talking about different units. Miles per hour. This one has 4 miles per hour. Going on to the last part, it says equivalent rates. We know the word equivalent means equal, okay? So this means they have the same unit rate. 16 miles per 4 hours is equivalent or equal to 4 miles per 1 hour. All right, for problem number 1, it says a nutrition label shows that every 1/4 cup of tuna has a 1/2 gram of fat. The question it asks me is, how many grams of fat are there for every cup of tuna? I want you to underline this right here. This is what came first. So everybody, let's write the word first. All right, and then over here we're going to underline cup of tuna because that is what came second. So the first thing it's asking us is how many grams of fat. Guys, how many grams of fat did the original problem tell us there were? 1/2. If you remember from yesterday, we're kind of writing a ratio. 1/2 to, what's the other thing we're comparing it to? Okay, 1/4 of a cup of tuna. How do we write that as a ratio? With the fraction bar. Okay, so I'm going to take the first one, 1/2 gram of fat, and divide it by 1/4. Okay, remember once again that division bar means 1/2 divided by 1/4. Hope, what should I do next?
KFC.
We are going to use KFC. So we keep the first one, flip the second one, and then change the operation. Jalen, can I cross-reduce anything there? The 2 and 4, what do they become? Very good. They become a 1 and a 2. Let's multiply that out. Gavin, what do you get? 2 is correct. Okay, so we talked about this yesterday. That's kind of like the value of the ratio. But now I want in a complete sentence, what in the world does that 2 mean? Going back to the question, it says, how many grams of fat are there for every cup of tuna? This is how you're going to write it. There are 2 grams of fat per 1 cup of tuna. Now looking at problem B, it says how many cups of tuna are there for every gram of fat? What looks different about question B versus question A? They flipped it. They're asking me for something different first. Does order matter when we're doing a problem like this?
Yes.
Yes, it does. It matters very, very much. So here you can see cups of tuna came first, and then the grams of fat come second. So guys, how many cups of tuna does it tell me we have at the original problem? 1/4. Okay, and then we're going to put it over, or we're saying 1/4 to 1/2 gram of fat. Noah, what does that fraction bar mean? To divide. So I am taking 1/4 divided by 1/2. Matthew, what do I do next? KFC. I've got to keep the first one, flip the second one, and change the operation. Ava, is there anything I can cross-reduce? What do the 2 and 4 become? Very good. And Einar, what's my answer? 1/2 is correct. Is there anyone who feels comfortable to tell me what the sentence would be comparing and answering the question, how many cups of tuna are there for every gram of fat? Amira, try it for us.
There are 1/2 cups of tuna of every cup of.
Okay, you're on the right track here. There's 1/2 cup of tuna per what, guys? Per gram of fat. Okay, 1 gram of fat. So here's the deal. When it asks you with this word right here, every gram, that means 1 gram. Okay, it's asking you how many cups of tuna are there for 1 gram. So your answer is correct. There is a 1/2 cup of tuna per 1 gram of fat. For problem number 2, it says there's 1/4 of a gram of fat for every 1/3 of a tablespoon of powdered peanut butter. The question asks how many grams of fat are there for every tablespoon of the powder. When do you think you might use powdered peanut butter?
Good.
Okay, yeah, you could have powdered peanut butter in a smoothie. How many of you have ever had like a peanut butter banana smoothie or something? Sometimes they even put chocolate into it. How many of you would prefer to keep your smoothie only fruit? All right. The question that it asks me first, it is asking for the grams of fat. Guys, how many grams of fat are there?
1/4.
1/4. You got to read it carefully, okay? So I'm going to start with 1/4. And then second, it's asking us about what? The tablespoon of powder. So what is that? 1/3. So remember, we're going to say it's 1/4 to 1/3. That's my ratio. Angeline, what does that mean when I have that big fraction bar there? You are correct. I'm going to divide. So this means 1/4 divided by 1/3. Isaac, what do I do next?
Then you do keep, flip, change.
Very good. Keep, flip, change. Keep the first one, flip the second one, and change that operation. Trenton, is there anything I can cross-reduce? No, there is not. So what's my answer? 3 over 4 or 3/4. Now I want you guys to help me answer the question. How many grams of fat are there for every tablespoon? Remember, that means every 1 tablespoon of the powder. Ava, what do you think? Uh-huh. That's perfect. There's 3/4 gram of fat per 1 tablespoon of that peanut butter powder, or the powdered peanut butter. Great job. For the next part, it says to find the unit rate. I want everyone to look at their notes. Just flip back 1 page, and I want you to look at where it says unit rate in our notes. Guys, read to me, what does the definition of a unit rate say? It compares a quantity to 1 unit of another quantity. So the key thing is, I want my denominator to be a denominator of 1. Let's look at number 3. It says to find the unit rate. So if I go into the store, it's basically saying I'm going to pay $1.32 for 12 ounces. So when we have talked about that before, that means $1.32 to 12 ounces. But how have I told you I would prefer you to write a problem like this? A fraction bar, very good. So instead, we'll write $1.32 over 12 ounces. Now, when asking for the unit rate, it is telling us here, I actually don't want it to know per 12 ounces. I want to know per how many ounces? Per 1 ounce. What could I divide by to get that 12 to turn into a 1?
2.
No?
4.
How can I turn that 12 into a 1?
12.
Divide it by itself. So I'm going to divide it by 12. If I divide the bottom by 12, what do I have to do to the top? You got to be fair to both. Now, if we're practicing with calculators in class, that means you may use it on homework, quizzes, and tests. So let's go ahead and put that in there, $1.32 divided by 12. When you come up with your answer, I want you to make sure you have units attached in both the numerator and the denominator. I'm hearing 11 cents, but what is that? 11 cents per 1 ounce, because when I divide that bottom part, 12 divided by 12 equals 1 ounce. So basically they went to the store and they got a deal, 11 cents per ounce. A lot of times parents will have memberships at like Sam's Club or Costco because they can get a better deal on their unit rate. Okay? All right, for the next one, I have 1/4 gallon for every 3/10 of a mile. What am I going to write down first? 1/4. Per what?
3/10.
Per 3/10. Hope, what do I do next? Okay, we're dividing 1/4 divided by 3/10. Huang, what do I do next? Okay, keep the first one, flip the second one, and change that operation. Guys, can I cross-reduce the 4 and the 10? A 2 can go into both of them. So what does the 4 and 10 become?
2 and a 5.
A 2 and a 5. Okay, because a 2 can go into a 4 2 times, and it can go into a 10 5 times. Talila, multiply that out. What do you get? 5/6. So guys, here's what this means. 5/6 of a gallon per 1 mile. Because if you remember, we want everything for a unit rate to have a denominator of 1. Does this seem like very good gas mileage?
No.
No. Okay, normally you want to get like 20 miles to the gallon maybe. And for this one, I mean, even RVs get like 5 miles to a gallon. So this has very, very terrible gas mileage. A scientist estimates that a jet of liquid iron in the Earth's core, so basically they're pumping liquid iron out of the Earth's core. They say it travels 9 feet every half an hour. How far does the liquid iron travel in 1 day? So we are comparing something. If I were to have a ratio, I could say 9 feet to what?
1.5 hours.
To every half an hour. When we write our ratios, most of the time we do it with a A fraction bar. So I'm going to have 9 per, or 9 to 1/2. This is 9 feet per half an hour. All right, so Trenton, what do I do? Very good. I'm going to divide. 9 divided by 1/2. And I'm just going to go ahead and put that over a 1. Trenton, keep going. What do I do? Very good. Keep the first one, flip the second one, change the operation. Hayden, what's the answer? Excellent. 18. Now, guys, give me units for that. What is that? 18?
18
feet
over 1.5 hours.
Over 1 hour. Now, listen, does this make sense? If I had 9 feet for a half an hour, does it make sense to have 18 feet for a whole hour?
No.
Why not? I'm doubling it. 9 times 2 is 18, and a half times 2 would be 1. So that does make sense. Now, here's my question. How far does the liquid iron travel in 1 day? Did our answer come out per day? No, it came out per what? Per hour. How would I change that hour into a day?
Divide by 12. Yeah. Divide by 24.
Do we know how many hours are in a day?
24.
24. So instead, I need to make sure that I am multiplying 1 hour times 24 hours to give me a day, right? If I multiply by 24 on the bottom, I also have to multiply it on the top. Okay, give me your answer in units.
432 feet in 24 hours.
432 feet in 24 hours. Now, going back to my original question, how far does it travel in a day? Does it tell me right there a day? Okay, 24 hours is a day, so instead I need to go ahead and change my units. 432 feet per 1 day. All right, number 5 says to tell whether or not the rates are equivalent. Guys, what does equivalent mean?
Equal.
Equal. I want you to raise your hand if you think these look equal. 20 pounds per 2 years and 35 pounds per 3.5 years. Raise your hand if you think, yes, they look equivalent. Raise your hand if you say, no, you don't think they are equivalent. All right, we're going to find out. And here's how you find out. By turning it into a unit rate. In order to have a unit rate, you must have a denominator of 1. Okay, that's very important. So let's look at the first one. 20 pounds per 2 years. I don't want a denominator of 2. I want a denominator of 1. How do I turn that 2 into a 1? I have to divide it by itself, which would be dividing it by 2. Then I'm also going to divide the numerator by 2. And then I want you guys to write down what you get with your units attached. Isaac, help me out. What'd you get?
10 pounds per year.
10 pounds per year. All right, so now what we have to do is we have to look at the next one and see about 35 pounds per 3.5 years. So we're going to start with the numerator, 35, divided by 3.5. Guys, how do I get that denominator to turn into a 1? Divide it by itself, or divide by 3.5 on top and on bottom. When you work that out, guys, what's the unit rate?
10 pounds.
Oh, 10 pounds per year. So what do you think? Are they equivalent? Yes, they are. Listen, guys, sometimes they don't look equivalent, but you have to turn them all into a unit rate of 1. So the denominator has to be a 1 so that you can compare the two. Let's go ahead and look at problem B. This is our last problem of today. 7 miles per minute and 420 miles per 3 hours. What looks different about this problem versus problem A? The units are not the same. The first one says miles per minute. The second one says miles per hour. In order to compare, you have to have the same units. So we will always take whatever the bigger unit is, and basically we will convert it to a smaller unit. Which one's bigger, minutes or hours?
Hours.
Hours. what do we know about minutes and hours?
There's 60 minutes in an hour.
There are 60 minutes in an hour. So instead of having 3 hours there, I've got to turn 3 hours into minutes. So what do I need to do to the 3 hours?
60 times 3.
Multiply it by 3 times 60. And when you do that, what do you get? 180. So 3 hours is the same thing as 180 minutes. All right, let's look at the first one. 7 miles per minute. How would I write that?
7:01.
Very good. 7 miles over 1 minute. Now, I want to have a unit rate of 1. Do I have a unit rate of 1? Yes, that means I don't have any more work that I have to do on that. I know it's 7 miles a minute. Now we want to turn the other one into 1 minute. Right now, what will I write as my fraction?
420 miles over 180 minutes.
Excellent. 420 miles over 180 minutes. I want you guys to turn your denominator into a 1. Okay, so in order to get that 180 to turn into a 1, what do I have to divide by?
180.
I have to divide by 180 on both the top and the bottom. Guys, what do you get when you did that?
2.333.
Okay, 2.3, and we're just going to write the repeating. Miles per 1 minute. Now let's compare the two. The first one is 7 miles per minute. The other one is 2.3 miles per minute. Are those equivalent? No, they are not equivalent.
I'm the one technically concentrating pretty fast.
All right, and that is the end of lesson 5.2 for today.